So let's look at an example. We'll run through qualifying for a first mortgage loan. We'll run through qualifying for a second mortgage loan, and we'll find out how much this individual can borrow with a first and a second mortgage loan. And then we'll ask the question, can they actually afford to buy this property? Which is perhaps the more interesting question for us. So let's look at that next. Okay. So we'll look at a gross debt service ratio and total debt service ratio example. So in this situation, we've got a purchaser who wants to buy the following property. Okay, here are the terms. The lending value is $307,000. Loan-to-value ratio is 80%, or 0.8. The borrower's income, $68,900, and the gross debt service ratio is 30%. The property taxes is $3,360 per year. And the interest rate on the first mortgage is J12 equals 6.5%, amortized over 25 years with monthly payments. And the question is, what is the maximum amount of the first mortgage? So how much first mortgage loan can they qualify for? So let's go through this example and answer it. Now I'll put this question up on the other side. Okay. So we're looking for the maximum first mortgage loan. So we'll look at the loan-to-value ratio, look at the gross debt service ratio, find the two maximums, and choose the lower of the two. So again, let's look at loan-to-value ratio first. So loan-to-value ratio, the ratio is 80% or 0.8. The lending value is $307,000. So $307,000 times 0.8 equals $245,600. So that's our first maximum. So based on the value of the property, that's how much they can borrow, and that's it. Let's also look at the gross debt service ratio and calculate that maximum. Okay. So the gross debt service ratio was the ratio itself multiplied by gross income minus taxes. The ratio given in the question is 0.3 or 30%. The income is $68,900 per year, and the property taxes are $3,360, also per year. So let's do that calculation. Okay. So that looks like $17,310 per year. So that's the maximum payment they can make per year. But if we go back to the question says the payments being made are monthly. So again, we'll take our yearly payments, divide by 12, and change them into monthly payments. So $17,310 divided by 12 equals $1,442.50 per month. So that's our maximum monthly payment. So if that's the maximum, we simply want to find the present value of the maximum payments at the interest rate on the loan. Interest rate is J12 equals 6.5%. It's J12, payments are monthly, so again, no interest rate conversion. So we haven't done interest rate conversions in the last few questions, but I'm always going to make a point of checking to make sure we don't have to. So let's enter the interest rate, 6.5%. It's J12. 12 periods per year. The payments that we've already found, 1442.5. And of course, I'm showing the payments entered kind of in order here, but as soon as you've done the calculation, taking your annual payments divided by 12 equals 1442, and that's on your screen, hit the plus minus key, hit the payment key, and enter it right away so you don't have to write it down anywhere. That's the easiest way to do it. And then enter the interest rate. Okay. So we've got our payment. We have to get N. It's a 25-year loan. So that's 300 periods. Zero future value. and we hit the present value key, and that will give us the present value. So we'll discount those payments over 300 periods at 6.5%, and that gives us a present value of $213,638. So we compare that maximum, $213,000, versus the maximum from the loan-to-value ratio, $245,000. You see that the loan-to-value, or the gross debt service ratio, again, that constraint is the maximum constraint. So that's the maximum loan, $213,000. That's the binding constraint. So very similar to the previous example. So you have $213,638. Now, we asked some questions about, well, could this person afford this? How do we know? Well, if the purchase price was also $307,000, so we'll assume the lending value and the purchase price are the same. If that was the case, then the difference between the $307,000 purchase price in this case and the amount that we can borrow is about $93,000. So the question here, like the previous question, do they have this much down payment? Well, in this case, we're going to assume they don't. They don't have this much down payment. They looked around, they can't find a better interest rate, they can't extend their mortgage, lengthen the amortization period. Their only choice is a second mortgage. Okay? If they're going to get a second mortgage, they're going to have to qualify for that second mortgage. So let's look at what the second mortgage terms are and how someone might qualify for that. So I'll include all this information on one slide together so we don't have to go back and forth. So let's look at the new information that we've got on this slide. So the new information we have is about the second mortgage. So the first piece of information is the interest rate on the second mortgage. It's J12 equals 9.5%. So it's higher. Does that make sense it's higher? Well, sure it does. Interest rates on second mortgages are typically always higher because a second mortgage has greater risk. In the event of default, the mortgage holders are paid out in priority. So first mortgage holders will be paid out first, and then if there's any money left over, second mortgage holders get paid out second. So some greater risk, and because there's greater risk, that means there's got to be a greater return. So you typically see higher interest rates on second mortgage loans, sometimes much higher. Well, what else do we know about our second mortgage loan? Well, the amortization period is 15 years. That's shorter. Also monthly payments. Total debt service ratio is 40%. And we're looking for what is the maximum amount of the second mortgage. So that's what we're looking for. Okay. So that's the same question we saw a moment ago. All right, well, let's work through this question. I'll leave it up on this side. So if we look at the total debt service ratio equation, let's look at that equation. I said a couple of minutes ago that the form of the equation that we would use to find the maximum second mortgage payment was this. The payment on the second mortgage, our maximum payment, is equal to the total debt service ratio times gross income minus the payments they're already making on their first mortgage loan minus property taxes. So we can use this equation to find the payments. Let's just fill in the blanks. Well, what do we know? We know what the total debt service ratio is. That's 0.4. We know what the gross income is. Well, that's $68,900. That hasn't changed. We know what our payments are on our first mortgage loan. These are the annual payments. And those were, scroll back and find out what they were, $17,310. And our property tax is $3,360. So 0.4 multiplied by 68,900 minus 17,310 minus 3,360 gives us $6,890 per year. Also keep in mind when you do this calculation, we're still following those continuous calculation rules. We do the multiplication first, then the subtraction. Don't do the subtraction first. You'll get a different answer, and that won't be the right answer. So we need to find the monthly payment because the payments on the second mortgage loan are also monthly. So again, we'll just divide by 12 and we'll get monthly payments. All right. So that is our maximum second mortgage payment, $554.17. So that's what we'll use to find the present value. So if we go back to the question says we've got a J12 interest rate equal to 9.5%. So we'll get both of those pieces of information entered. 9.5% interest rate, 12 periods per year. The payments themselves are $574.17. So we'll enter our payment. It's a 15-year loan, monthly payment, so 15 times 12 is 180 yen. Zero future value, and we'll calculate a present value. So we go through the steps, calculate a present value, comes out to about $54,900. So that's the second mortgage loan. So a second mortgage loan, of course, is much less, much lower than the first mortgage loan was. And it's lower because, A, the total debt service ratio is higher than the gross debt service ratio. And this calculation already includes the fact we're already paying and qualified for the first mortgage loan. So it will be less, of course. So my question now is, we've answered the question, how much loan can this person qualify for? Well, $54,985 is the answer. So in terms of this question, we finished. But I think a more interesting question is, can this borrower actually get all of this second mortgage loan? Well, how do we know? What do we compare it to? Well, if we look at the maximum second mortgage loan they can get, $54,900, and we add it to the maximum first mortgage loan they've already qualified for, $213,000, what does that total? If I add up the two loans together, I get about $268,000. That's what he's trying to qualify for. And I said, can he get it? Well, what else do we have to think about? The other constraint. Remember the loan-to-value ratio constraint from a few steps ago? Well, what was the maximum based on the loan-to-value ratio? 245,600. So now they're running into the other constraint. So we can borrow all of the first mortgage, maybe part of the second mortgage loan, up until he butts into the $245,600 ceiling of the other constraint. So what do you do now? Well, this person wants to buy this property, you want to sell the property, now what happens? Well, how do we deal with the other constraint? We want to go above 0.8%, because that loan-to-value ratio constraint was based on 80%. Maybe we need to go to 85% or 90%. So now maybe we need to have the insurance discussion. Absolutely. We want to push that up a little bit. So that's how these constraints work together. I'll say work together instead of conspire against the borrower, because there's really two sides of the street. One is, of course, as you manipulate the different constraints, you can borrow more and more, which is beneficial in terms of being able to purchase a more and more expensive house. But of course, the downside is that you still have to pay all this money back at some point, right? Okay. So the maximum loan-to-value ratio is 245,000. Maximum first mortgage is 213. So perhaps they'll only be able to qualify for part of the second mortgage loan. So about 31,000. So maybe they'll be able to qualify for that amount if they weren't able to raise the loan-to-value ratio constraint. If they were able to raise the constraint, they can borrow some more, and they can certainly go above 80%, borrow more, and perhaps buy the property. Okay. So a couple of things in this example just to take away. One is certainly this idea of there's two constraints. Loan-to-value ratio is one, gross debt service ratio is another, capital value versus income. When we talk about second mortgages, we introduce a third constraint, and that's the total debt service ratio constraint. Functions much like the gross debt service ratio. It just includes at least one other term, which is the payments the individual is already making on their first mortgage loan. Once we get the maximum maximum payment rather, just make sure if it's annual, which is what comes out of our equation, just make sure it matches the question. So if the question has monthly payments like ours did, make sure it's a monthly payment. If you don't make it into a monthly payment, you use the annual payment, and you find the present value will probably be millions of dollars. It'll be really out of whack, so it'll seem wrong. So that's a common mistake. Otherwise, these are just present value questions. We've done lots of present value calculations, nothing too new there.